Okay, so we're going to continue with factorising. Very similar to the last video, but the examples, as I said, will be a little bit more challenging. So you're still going to see the 4 sections that we looked at in the last video. So I'm quickly going to run through the first few and then spend a little bit more time when it comes to the quadratic trinomials. So first of all here, remember highest common factor, you're taking out what both terms have in common. Okay, so it's the highest number or letter that both terms have in common. So here we can see 5 divides in to both 5 and 25, so we have to take that out. And you can also see they both have a y. So we've taken out 5y, so we're left with y, because 5y times y is 5y squared. And we're left here with 5 times 5 gives us 25, and the y has already been taken out. Okay, and remember we said it's the opposite to expanding, so if we were to multiply this back out, we would get what we started with here. Okay, 2 and 15 don't have any number in common, so we're just taking out a here, and we're left with 2a minus 15. And then the same here, 3 and 11 don't have anything in common. So we're just looking at the variables here. So we're taking out the p and we're left with 11p minus 3. Okay, so that's as difficult as it would get with the highest common factor example. So still very straightforward. Okay, now difference of two squares. Remember all of our terms, okay, must be written as squared, and it always has a negative sign between them. So that's how we're identifying, okay? So we have a squared term and a constant and a negative in between. We can rewrite this as 2 squared x squared minus 4 squared. So remember, we're rewriting when we're factorising. We're not actually changing anything. So 2 squared is the same as 4, x squared is the same as x squared, and 4 squared is the same as 16. So we actually haven't changed anything. We've just written it in a different form. Our answer is always as back-to-back brackets. So it's going to be 2x minus 4 and 2x plus 4. Final answer. And remember, we said if we expanded the back-to-back brackets, we'd end up with this here. Okay. Next one again, 64 can be written as 8 squared, x squared, and 49 can be written as 7 squared. So we have back-to-back brackets, 8x minus 7 and 8x plus 7. And just to make a point there about our signs, if you did 8x plus 7 here and 8x minus 7 here, that would be absolutely fine. Okay, the order of the signs doesn't matter. So final answer there. Next one, we've 81 is the same as 9 squared, y squared. 196 is 14, is it? So square root of 196 gives us 14, yeah. So minus 14 squared. So our answer is 9y minus 14 and 9y plus 14. Okay, so remember just there for your numbers, if you're unsure, the opposite to squared is square root. So the square root of 196 gives me 14, which means 14 squared is the same as 196. Okay. Next one, 169x squared minus 324. So 169 is 13 squared, x squared. The square root of 324 is 18 squared. So our answer here is 13x minus 18, and 13x plus 18. Okay, so very, very straightforward. But just you should be able to see the difference in part 1 and 2 in this section compared to the last video. So just make sure you can see the difference between those. Okay, gonna move on. Part 3 is our quadratic trinomials. I don't think I've done grouping here. No, we've left out grouping, but you're not going to see much difference in grouping from the last video to this video, okay? So number 3 is our trinomials, okay? And what you should be able to see here, in the last video we said quadratics are written as ax squared plus bx plus c, and a, b, and c are just numbers, and the x's are the variables. Okay, so the x squared and the x will always stay as they are. Okay, so what you should notice is the coefficient of x squared. Now, if you remember from the very first video, the coefficient is the number in front of the letter. So this is a coefficient here, the a, and the b is a coefficient here. Okay, if we look at our coefficients in the examples, the coefficient here would be 2 is the coefficient of x squared, 5 is the coefficient of x, 3 is the coefficient of q squared, 8 is the coefficient of q, 7 is the coefficient of x squared, 2 is the coefficient of x, 4 is the coefficient of x squared, and here minus 1 is the coefficient of x. So just make sure you understand what the coefficient is. So it's the number in front of the variable, okay? And in these examples, okay, in the first video of factorising, there wouldn't have been a coefficient greater than 1 for the x squared. So it just would have been x squared, it just would have been q squared, it just would have been x squared, and it just would have been x squared. There'd be no number in front of that. So this means that it's a little bit more challenging to factorize. So I'm going to go through the guide number method to help us actually solve this, and our factorize by grouping is actually needed within this section, so it's important to make sure you look back on the last video that you understand how to use factorize by grouping. So for the guide number, the first thing we do is multiply the coefficient of x squared, which is 2, and we multiply it by the constant, okay? And that means our guide number for this question is equal to 6, okay? We're going to use the factors of 6, so it's either 1 times 6 or 2 times 3. So we're going to use the factors of 6, okay? And we are going to rewrite the middle term, okay? So the 5x here, we're going to rewrite using 2 of these factors. Now in this example, it actually ends up that you could use 1 and 6 or 2 and 3. But if you try to use 1 and 6, you'll end up with a negative because 6 minus 1 is 5. And because there's no negatives in this question at all, I'm going to just go straight and use the 2 and the 3, because 2x plus 3x gives us 5x. So remember I said I'm rewriting this. So we've 2x squared. Instead of 5x, I'm going to write plus 2x plus 3x, and there's a plus 3 at the end here. So keep in mind, if you look at these two, I have not actually changed the question at all. I've rewritten the 5x as 2x plus 3x. And you should see now that you now have 4 terms that we need to factorize. And remember in the first video of factorizing, when we have 4 terms, we use factorize by grouping. So we group the first 2 terms together and then the second 2 terms together, and we're going to factorize them separately. So if we look at 2x squared plus 2x first, we can see they both have a 2 in common and they both have an x in common. And if I've taken out 2x, I'm left with x plus 1 times 2x gives 2x. Just be careful there. If we look at the next 2 terms, the only thing they have in common is a 3, and we're left with x plus 1 again. Now, remembering from the last video, our final answer for factorize by grouping is our back-to-back brackets. The 2 outside terms, which I've underlined in red, they go together in one bracket, and then the repeated bracket is written beside it. Okay, there's other ways we can solve quadratics. You might remember the minus b formula, or the quadratic formula. You can also use trial and error, which might take a little bit more time. I like the guide number method because it's something that I know will work every single time and won't waste a huge amount of time if you're in an exam. And then when it goes on to solving, remember we're not solving at this point because there's no equals 0 here. When you go on to solving, it could be useful to use the minus b formula or the quadratic formula, which I'll go through when I get to that section in algebra. So let's continue with our guide number method for the moment. So to find our guide number in the next question, we multiply the coefficient of the x squared term by the constant. So 3 times 4 gives us 12. Factors of 12 are 1 by 12, 2 by 6, or 3 times 4. Now we have to pick the factors that we could rewrite 8q with. So 1 and 12 doesn't work, 3 and 4 doesn't work, and we can see 2 and 6 could add to give us an 8. So we're keeping the 3q squared, okay? We're going to now add plus 2q plus 6q, and we're just keeping the plus 4 from the question. So remember what we've done here is rewritten the 8q as 2q plus 6q, which is 8q. So we haven't changed anything to suit ourselves. We've just rewritten as two terms. So what we're going to do next is looking at factorize by grouping. We're going to do two terms at a time. So 3q squared plus 2q. The only thing they have in common is a q. So I'm taking out the q. I'm left with 3q plus 2. And here they have a 2 as the highest common factor. So 2 is the highest common factor of these two terms. 2 times 3 gives us 6, so we have 3q. And 2 times 2 gives us our 4. So we notice again, and I said this in the last video, our two brackets have to be the exact same here. And if they're not, then it's a good hint that you've gone wrong somewhere. Final answer is our back-to-back brackets. The two outside terms go together in one bracket, so q plus 2. And the two same terms go in the next bracket, and that's our final answer. And keep in mind, we would have said this as well in the previous video, if I was to expand these brackets, okay, multiply them out, I would always end up with what I started. So factorising and expanding, you're always going to end up with the opposite. Okay, next example, we've 7x squared plus 2x minus 5. So remember, our guide number is found by multiplying the coefficient of x squared by the constant. So 7 5s is 35. We have factors of 35, 1 times 35 and 5 times 7. Okay, so we're trying to replace the plus 2x in the middle. So the only two numbers that would give us a 2 here is the 7 and the 5. We need to be a little bit more careful here. We're looking for a positive 2x. Okay, so we're going to give the positive to the 7x. So plus 7x minus 5x is the same as 2x. And I've just carried on the negative 5 there from the question. We've our 4 terms, which always kind of rings a bell and tells us, okay, this is factorised by grouping. 7x squared plus 7x. So they have a 7x in common. And we're left with x plus 1. Okay. Here we need to be careful. We're taking out minus 5. So minus 5 times x gives us minus 5x. And minus 5 by plus 1. Minus by a plus gives us minus. So if you put a minus in here, it will be minus by minus gives plus, and you'll have actually changed the question. So it's positive 1 here. And then our final answer is our back-to-back brackets. 7x minus 5 and x plus 1. Okay. And the last example we have here. So 4x squared minus x minus 5. So 4 multiplied by 5 gives me my guide number, and 4 times 5 is 20. Factors are 1 times 20, 2 times 10, or 4 times 5. Now remember here, I'm just going to write it in. We are looking for a minus 1. So 1 and 20 is not going to work. 2 and 10 is not going to work. But 5 and 4 can work to give us a negative 1. So I have 4x squared we need to get a minus 1. So it's going to, we're going to have to make sure we give the higher number the negative. So it's going to be minus 5 plus 4. So minus 5 plus 4 gives us minus 1. So I'm going to write plus 4x minus 5x gives us minus 1x. And the minus 5 is from the question. Okay, we have our factorised by grouping. So we're taking out here our 4x and we're left with x plus 1. We're taking out minus 5 times x plus 1. So our final answer is 4x minus 5 times x plus 1. Okay, so I'll give questions at the end, and that one will need a bit of practice. I'm not sure if you would have seen that method before. So very useful, and as I said, something that works all of the time with quadratics. So useful in that you're not going to waste too much time just kind of messing around with different factors for different numbers. Now the last section I'm going to look at in this video is simplifying algebraic fractions. Now this is important that we look at it now because you're going to see examples of highest common factor, you're going to see examples of difference of two squares, and you're going to see quadratic trinomials, and you're going to use each of those to try simplify these fractions. Okay, this is very important here from indices, and we will have to look at indices at another time. But when we are dividing, okay, remember indices is working with powers, okay, or indexes. So we're working with powers here. So the same base, okay, when we're dividing, we subtract the powers. So for example, if we've x to the power of 5 divided by x to the power of 3, it becomes x to the power of 5 minus 3, which is x squared. If we had y to the power of 12 divided by y to the power of 4, we would have y to the power of 12 minus 4, which is y to the power of 8. So keep in mind, it has to have the same base for this principle to work. Okay, so the base there is the letter. So let's look at this. We're going to look at it in numbers divided by numbers, and then variables divided by variables, or letters divided by letters. So first thing I can see here is 16 divided by 4 is simply 4. A to the power of 5 divided by a to the power of 2. By using this principle, okay, dividing our indices, what you're looking at is 5 minus 2 is 3. So our answer is a to the power of 3. Top line here, we can factorize this using the highest common factor. So the top line becomes x times x minus 4, because x is the highest common factor of these two terms, and that's divided by x minus 4. Now this can be simplified further, okay? 3 over 3 is the same as 1, x over x is the same as 1, 7 over 7 is the same as 1. Anything over itself is 1. So if I have x minus 4 over x minus 4, well then it also is the same as 1. So what we end up with here is x times 1, which is just x. So final answer there is x. Okay, top line here we've 10x minus 5. So 10x minus 5, highest common factor is 5. And we're left here with our 2x minus 1 over minus 5. Okay, I was just checking that question to see if I'd taken it down correct. But yeah, so what we're looking at here, 5 over minus 5 is minus 1 times 2x minus 1, which is the same as minus 2x plus 1. Okay, so just be careful of our signs there. 5 over minus 5 is minus 1. Okay, next question. We've our back-to-back brackets. Okay, because we're going to solve a quadratic trinomial. Easier example, so x times x gives us x squared, 5 times 2 gives us 10, plus 5x plus 2x gives us plus 7x. So that's our top line factorised. There's nothing we can do with that bottom line, but you should notice again, x plus 2 over x plus 2 is the same as 1. So our answer is x plus 5. So x plus 2 over x plus 2 is 1. X minus 4 over x minus 4 is 1. Top line doesn't have anything in common here. Bottom line, we're going to use our guide number method. So our guide number here is going to be 2 times 27, which is 54. Factors of 54 that would add or subtract to give us 15 is 6 and 9. So this is going to be 2x plus 9 over, we're going to rewrite the middle term. So 2x squared plus 6x plus 9x plus 27. Bottom line, we need to factorize by grouping. So we have 2x plus 9 on the top line, that doesn't change. So 2x plus 9. Underneath, we're going to take out the 2x and we're left with x plus 3. We're going to take out the plus 9 and we're left with x plus 3. So to simplify, we've 2x plus 9 over, remember the two outside terms are in the first bracket, so 2x plus 9. And then we're multiplying by x plus 3. And if you notice again here, 2x plus 9 over 2x plus 9 is 1. So our final answer here is 1 over x plus 3. Okay, so just be careful there. So this becomes 1 over 1. So it's 1 over x plus 3. Final answer. And the last example that you would see of this is our difference of two squares is on the top line. So 25 could be rewritten as 5 squared, x squared. 169 can be written as 13 squared, and that's over 5x minus 13. Back-to-back brackets at the top, so we 5x minus 13, 5x plus 13 over 5x minus 13, and as you can see, 5x minus 13 over 5x minus 13 is 1. So our final answer there is 5x plus 13. Okay. Fractions, people kind of have a love-hate relationship with fractions. A lot of people don't like them. So I recommend going back over the fraction part of the video a couple of times just to make sure you're okay with it, or even watch the video again as you're going through the questions. Okay, so that's our second video on factorising. I'm going to send on some questions also that follow on from both factorising videos. Okay, so that's the questions there, but I'll send them on also.